elimination method. And basically, for the elimination method, you are going to eliminate one of the variables and then solve for the other variable. Most students tend to think that this method is a little bit easier than substitution. Now, you'll see the words elimination method with addition and subtraction. So you'll have to decide, do I need to add these together or subtract them in order to eliminate, word elimination, in order to eliminate one of the variables. Now these are set up in a special way. Notice the x and the y on the left equals to the constant. X and y equals constant for each one of these. When we get down to the bottom, they're not in this order, so we'll have to rearrange them so they look just like the top part, okay? They have to be in this order to use this method. So we still have the same directions, solve each system. So that means we're still looking for that answer that's a coordinate. We're just using a different method. All right, that's very important to understand, okay? So notice in all of the problems at the top, you'll see the same coefficients, like negative 1x, negative 1x. Here, negative 5x and negative 5x. Here, the 7y's are the same. And here, the x's are the same coefficients. So what you want to do is you want these to have the opposite signs of each other. Like one's negative and you want one to be positive, so they'll cancel each other out. So do I add them together to make them cancel out, or would I subtract them to make the two variables cancel out? Correct. So I would subtract, because if I add them together, let's say I put a plus sign here, okay, which is not correct. So if I put a plus here, a negative 1 and a negative 1 is going to give me a negative 2x. That is not what I want to happen. I want these to cancel out. So I am going to put a minus sign here. Because when I put a minus sign there, a negative 1 minus a negative 1, really, if you look at it, a negative 1 minus a negative 1 changes this to a positive, and now it equals to 0, which is what I want it to happen. So I'm just going to cross them out and say they are eliminated. Okay? So once you do that, eliminate one of them, that's why it's called elimination method, then you solve what's left. Now, keep in mind, that's a minus, we are subtracting. So what is 4 minus a negative 7? It's really 4 plus 7, 11y. Okay, so you got to be very careful when there's a minus there, because it technically changes the sign of everything on that second row. Okay. All right. Here, negative 19 minus 25. So negative 19 minus 25 gives us what? Negative 44. Is that correct? So then you just solve it just like you would an equation, because it is. And you divide by 11. So you get y equals negative 4. So again, it's a little bit faster than substitution, okay, because you eliminate one of the variables right away and solve for the one that's left. Now, I'm not finished, because which variable am I missing? X. So all I have to do now is go back to the first equation or the second equation and replace y with negative 4 and solve for x. It does not matter which one you replace it with. You can do it in the first equation or the second, you will get the same answer. I'm just going to start with the first. So I'm going to go back up to the first, and where I see y, I'm going to replace it with negative 4. Okay, so that's going to give me negative x minus 16 equals negative 19. Add 16 to both sides. Negative x equals to negative 3. And when you divide by the negative, you get a positive 3. So same thing, write my solution as a coordinate, 3 and -4 for y. So in number 2, I'm going to put a minus sign again because I want the bottom one to be a positive. Okay, so that eliminates those x's right away. And now I'm going to do, because really there's a 1 here. So 1 minus 6 will give me -5y. And -25 minus a negative will be really -25 plus 25. And that's 0. Okay, divide, I get 0. Done. Already got one of my variables. Put it back into whichever one you want. I'm going to do the top one. So -5x, I don't even need to say plus 0. I'm just going to say equals -25. Divide by the -5. So x equals to +5. And then there's your solution. Okay. How many people think this is easier than substitution? It is. It's a whole lot less steps. And you're finished pretty fast. The thing is now, because you might say, well, what if they don't cancel out right away by adding or subtracting? We're going to get to that lesson another day, okay? Because there's something else you can do to make those variables disappear. So we'll do that lesson on another day. Today, they will work out just by either adding or subtracting them together, right? So let's look at number 3. So in number 3, I'm still subtracting because I want this to turn to a negative. So those y's will cancel out, okay? So I'm going to do 2 minus a -8. Well, that's really 2 plus 8 is 10. Y's cancel out. And -13 minus 17 will give us negative what? 30. And then I divide by 10, and x equals to -3. Okay, I'm just going to do the first one again. You can do the second one if you like. It really doesn't matter where you substitute that answer. So I'm going to do 2 times -3 plus 7y equals -13. So -6 plus 7y equals -13. And then add 6. So 7y equals 7, so y equals to 1. So your coordinate would be -3 and 1. Now, sometimes, like on a standardized test, like your SOL and things like that, they might just ask you for one of the answers. They might just say, give me the x value. Then, of course, you would just say -3, or they might say solve and just give me the y value. Okay, so you just got to really pay close attention to directions. Okay, all right, so we caught that mistake. It's -1, not positive, because this is negative. This should be a -7. So yes, that's a -1. All right. All right, so let's move on down to the bottom. Now you have to change these on your sheet because they are not the same problems. So go ahead, I'll give you a chance to write these down. Okay, because you should not have, these are not the same numbers you have. Is that correct? Yours the same? Okay, all right, hold on. All right, so these are the ones that you need to change on your paper to this. Cross out the ones that are there, because we're not going to do your 5, 6, 7, and 8. We're going to do these 5, 6, 7, and 8. So just replace them with this. Okay. So we're going to do at least 5, 6, and 7. So just write those down, and then we'll work these out. So we are still using the elimination method. However, it does say write in the correct order first. So these are not in the right order. Remember when we started the first 4 problems, we said the X and Y have to be on the left. All right, so we just use the opposite side to get it across the equal sign. So I'm going to move this over, so that's going to make that a positive 9y. Move the X over, so that's going to make that a negative X, and let me just slide this over a little bit. And then I have to move the 5 over, so I'm going to add that over to here. So it has to look like that. The X and Y, you know, they have to be on the left. So here, I'm going to move the X term over, so that's going to make that a positive X when it gets over. 9y can stay, and the negative 5. I only had to move the X term over. Now this time, what do you notice about the X's? They're opposite signs. So I'm not going to put a minus sign. I am going to place a what? Addition. Okay, because I don't need to change them. They already have the opposite side. One is already negative, one is already positive. They're going to automatically be eliminated. So when they're automatically eliminated, they already have opposite signs. You put a plus. You combine them together by adding. So now I'm going to have 18y equals to 0. So that's just going to be 0 when you divide. And again, you can go back to your first or second one. Okay, I'm just going to go up here to this one here and say negative x. I don't even need to write plus 0. And then when you divide by the negative, that'll give you negative 5. So your coordinate is negative 5 and 0. Okay. A lot less steps to do. All right, let's get number 6 in the right order. Okay, let's get number 6 in the correct order. So in number 6, I just need to move the y over and move the negative 25 to the other side. So negative 9x minus 10y equals positive 25. Because I put that over here, put that over there, change the signs. I'm going to write down the second equation. Okay, that's already in the correct order. And since they already have opposite signs, I put a plus. All right. X's cancel out automatically because I have a positive 9 and a negative 9. Okay, here, a negative 10 plus 8 is going to give me a negative 2y. And 25 minus 11 gives me 14. Okay, divide by negative 2. And y equals to negative 7. Okay, so I'm going to give you guys a chance to substitute negative 7 back into the first and second equation and find out the x, and I'll just ask someone for the answer. You should be able to do that on your own. Okay, you want to tell me the answer? So your x is 5. Okay, how many people got 5? All right, so we'll write it as 5 and negative 7 as the coordinate. So again, like, you know, if you wanted to check it, you could replace x with 5, replace y with negative 7, and see if it equals to 25. And then do the same thing and see if it equals to negative 11. So that's how you would check your coordinates. All right, we're going to do one more. So then we would have done 3 with subtraction and 3 with addition. All right, so let's take a look at number 7. We need to rearrange this. We need to move that y to the other side. So we're going to have 8x plus 6y equals to 30. And then at the bottom, we have the negative 8x minus the 6y, and then we're going to move this 30 over, so that's negative 30. Now, what do you notice here? Looks like everything cancels out. Is that true? So we have 0 equals to 0. So what do you think I should write? Infinitely many solutions. Exactly. So when everything cancels out like that, that means they're the same line, graphed twice. That means it's infinitely many solutions. Okay. And that's today's lesson.